Let's dive into the core techniques that will help us use large language model in our application. Getting a handle on these core techniques is key to effectively using large language model in building AI-powered solutions. Let's see the core techniques we need to effectively use large language model in our applications. First up is prompt engineering. Think of it like giving instructions to an AI. The better your instructions, the better the AI responds. The second one, we have retrieval augmented generation, RAG. This is where the large language model can assess external information to give us more comprehensive and informed answer. It's like having the AI do additional research to back up its response. Then there is fine-tuning. This is where we customize a pre-trained large language model for a specific task, making it more accurate and efficient. It's like teaching the AI to be an expert in a particular field. So at last, we have the agentic patterns. This is a relatively new concept for AI agents to work together. It's kind of like a team. Later, we will see more of the frameworks that work in these patterns. And these patterns, this allows us to do more complex and sophisticated AI-driven solutions. So understanding these core techniques is essential for us in building AI applications using large language model. When we start talking or when we start working with large language model, we usually have to start with system prompts. They are the underlying instruction we usually give it to our large language model. It guides its behavior and responses. So before we send any other messages to it, we set the system prompt. A well-crafted system prompt is crucial as it directly impacts how our AI application functions. It sets the boundaries or provides the context or defines the overall tone and styles of the AI's interaction with the applications. For example, let's say we can use the system prompt to make the AI more informative or creative or even funny. This is how a lot of websites are trying to make it a lot of other agents or the bots acting like girlfriends or enemy characters. So the flexibility of system prompts allow us to tailor the AI's behavior to suit the specific needs of our applications. To help us get started, there are many resources on GitHub with a collection of system prompts that we can learn from and adapt as we need. Here is an example of a system prompt used by Claude 3. It is quite extensive, covering various aspects like identity, behavior, and limitations. So this level of detail is why it is often called as a mega prompt. It's this huge chunk of text that is designed to frame or give the behavior of this large language model. So the key takeaways is like the importance of clearly defining the AI roles and capabilities. Have to be super clear, and this also could provide like safety guidelines and setting some expectations when it interacts with the user. So this example that you're seeing shows how a well-crafted system prompt can significantly shape the AI's behavior and responses. A good example for us to learn. So in the system prompt or subsequent messages, we can use other techniques to give instructions to AI model to get the desired output. There are different techniques, including zero-shot, one-shot, and few-shot prompting. Zero shots provide only a task description directly with no example, whereas one-shot gives a single example, and few shots provide a few examples for AI to learn and follow. Other techniques include chain of thought prompting for complex tasks, or automatic reasoning and tool use for selecting demonstration from a given task library. And another one could be like reason and act for generating reasoning traces and interfacing with external tools when it do the acting. So there are many more techniques to explore and learn. So I won't go deep into each of this, as there is a website listed with a myriad of techniques and details to explore. Read more in the prompting guide to AI. As we discussed earlier, prompts are like giving instructions to the AI. The better our instructions, the better the AI response. So being skillful in prompt engineering techniques is a critical skill for us to work with various large language models. Here's the index of good size that I usually explore whenever I need to program with large language model. There are good example prompts that we can refer to. Let's move on to our next core techniques, retrieval augmented generation. This approach involves more work than just prompt engineering. So why do we need RAG? The key point here is that RAG enhances AI language model by retrieving relevant information from external sources. That is the retrieval part. So this means it can pull in data from the web or wikis or books or specific organizational data set in the databases to augment the input prompt. So the result is that the model can generate more accurate and informed responses to the queries. So the key point is that it helps the AI to be more up-to-date and context-aware by leveraging the additional information beyond its pre-training data. Like, as you know, the GPT-3, GPT-4, they all have a date of their data sets. Beyond that date, the AI does not understand or does not know that information. So this makes the AI responses, the RAG makes the AI responses not just more accurate, but also more relevant and useful. We will see the example. So let's take the example of how RAG works with the chat history. Just receiving the information alone and answering that would be like a search engine, right? But you need to interact with that information. So this working with the chat history is something quite a popular example to try with. So the system in this design, the system gets the user new question along with the previous chat history. So it searches for relevant document from the external sources, which could be like a splitted document store in the vector store, and it can also prioritize the most relevant document after its search. Some call it re-ranking. The chosen documents are like prepared for the language model to use. So then the language model creates a response using both the new question and the chat history. So the updated chat, including the new questions and response, is saved for the future reference. This approach makes the AI leverages past interactions and external data to provide more accurate and contextually relevant answer. This makes the responses not just accurate, but also contextually aware, enhancing the overall user experience. This is how RAG can be mixed in the bigger solution to make it more useful for the user. Let's look at the next technique, fine-tuning. Fine-tuning involves taking a pre-trained language model and further training it on a smaller, more specific dataset. This process helps the model become more proficient at a particular task or understand a specific domain better. Why do we need this? A pre-trained model is like a general purpose tool. It's good at many things, but not specialized. When we need the model to excel at a specific task, like summarizing legal documents or translating medical text, fine-tuning is essential. For example, if we want a language model to serve as an effective call center customer support bot, we would fine-tune it using a dataset of previous recorded common customer inquiries and responses from the agent specific to that industry it will be serving. So fine-tuning transforms a versatile tool into an expert one, tailored for precise tasks, enhancing performance and accuracies in specialized application. So cost-wise, pre-training a model is expensive and computationally demanding. Not everyone could afford it. But fine-tuning is much cheaper and less resource intensive. This allows us to adapt the model to specific needs without high cost. The data set for fine-tuning must be high quality and relevant, of course. For example, using a data set of customer service queries helps the model respond accurately to the similar questions, like as if the actual customer agency is responding. So the fine-tuning is like supervised learning in the machine learning because it uses labeled data to teach the model to have the correct outputs. So it is cost-effective ways to specialize a pre-trained model, leveraging smaller data sets for specific areas. Remember, to do this, you need a good quality data set of specific domains or examples you want to fine-tune on. How easy it is to fine-tune? There are many ways to do it. On the OpenAI, it provides a very user-friendly interface, as simple as uploading the labeled data file to fine-tune your selected models. The providers like Microsoft, AI Studio or Mistral or Google Vertex AI, they all provide a similar service for fine-tuning. Or if you want to fine-tune using an open model yourself, like Llama 3, you can do so with the code directly on your own computer as well. Here's a list of articles that you can look at and start playing with fine-tuning if you want to code yourself. So the next is agentic patterns. And this concept, mentioned in the batch update by Andrew Ng, highlights an important shift in AI, using multiple agent workflows to iterate, collaborate, and refine the outputs. So this approach significantly improves performance compared to traditional single-shot methods. Here are the 4 key steps that involved in this design pattern. So understanding and applying these frameworks is crucial for all of us to build better systems. So when we talk about agent, there are like basically two patterns. One is single agent architecture or multiple agent architecture. So single agent model is very good at narrow, well-defined tasks, but it may struggle with long subtask sequences. The multi-agent architecture breaks down the complex problem into smaller specialized tasks handled by collaborating specialized agents, enabling parallelizations and robustness on handling these tasks. Whichever the architecture we're using, any effective AI agent systems share some key elements such as well-defined prompts, clear task division, dedicated phases for reasoning, planning, execution, and evaluation in that dynamic team structures. Whether it is human or AI will provide the feedback, and this intelligence message filtering between each other communication. So this optimal architecture depends on the use case and also incorporating various factors, just now we mentioned, in generally to enhance the performance. There are a lot of factors that we need to consider and make it clear for each of these agents to be effective. So let's look at the detail of reflection pattern. This pattern enables the agent to learn from its own mistake and iterate on its performance, leading to continuous improvement like people do, and by improving its abilities and decision-making processes. So by using the reflection into the design of the AI systems, we can enhance the overall performance and effectiveness of the agent, even for the damp models. The next one is tool use. This pattern is to empower the agent to leverage external resources and capabilities, expanding its range of action and enhancing its problem-solving abilities. So by adding tool use into the AI system, we can create more versatile and effective agents which can use these tools. We will learn more about how this tool use is enabled by the language model and as well as in various software frameworks. So the planning patterns enables the AI agent to break down complex tasks into smaller, manageable subtasks. The AI dynamically decides the best sequence of action to achieve the desired outcome. For example, if the task is to cook a potato and put it into the recycle bin, well, that really makes sense, right? The AI planner in this case will break down these tasks into multiple steps, navigating to the potato, picking it up, and placing it in the recycle bin. If it encounters obstacle like not finding the potato, but seeing a fridge, it adapts its plans to open the fridge instead of picking up the potatoes directly. So this process allows the AI to handle the task more efficiently and adapt to the changing environments by planning itself with the new given information. Multi-agent collaboration pattern is about making multiple AI agents to work together by splitting the tasks based on assigned role for its own specialty. The communication between each other is to achieve the common goal, of course. So this is how a team of autonomous agents that can reason, plan, use tools, and complete the task end to end, like a team of experts working together for the common goal.